How's it going? It's time for another daily coding problem. These are problems that I've been doing for about a month now. I've just never been really good at these types of problems, so I'm trying to practice them every day or almost every day, except for the weekends. I'm taking those off so I can go outside and play. And I'm using two sources for these questions. One is the top interview question list on LeetCode and LeetCode.com if you're not familiar. And then the other is a email newsletter called Daily Coding Problem. Every day you get an email. It has a problem in it and it says what company that question was asked at. The ones on LeetCode are supposedly actually asked at tech companies as well, but they don't tell you what company those came from unless you pay for their premium service, which I don't. I'm just there hanging out. So the one we have for today is from dailycodingproblem.com. Let's take a look at it now. This problem was asked by Google. Given an array of strictly the characters R, G, and B, segregate the values of the array so that all the R's come first, the G's come second, and the B's come last. You can only swap elements of the array, meaning you can't use any other vehicles for storage. Do this in linear time and in place. For example, given the array G, B, R, R, B, R, G, it should become R, 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 G, G, B, B. Or sorted, basically. So not all questions have these types of requirements here. I'm noticing Google and Microsoft, and I think that's the only two, or Amazon as well. Those are the companies I've seen that tend to care about these things. Some specifically say they don't care about them, like Stripe, for example. So Google here calls out that we need to do this in linear time and in place. So we can't use like a separate array for the R's and a separate array for the G's and a separate array for the B's and then merge them at the end. We can only do swaps in place, which means we can probably use a couple temporary variables, but that's it. And then linear time, meaning we want to go through our input a constant number of times. So either one time or two times or three times, but we don't want that number to scale as the number of elements in our input scales. It has to be constant. So linear time and in place. So what I'm thinking when reading this problem, a solution that came to me that satisfies these requirements, and the one we're going to go with today, is using 3 pointers to sort our array. We're going to have one pointer that points to where the R's go, one that points to where the G's go, and one that points to where the B's go. And if I were to draw this out here, for example, let's actually, I'll just copy this right here. I'll copy our actual input. It would look something like this. So we have our R pointer, which is pointing to the 0th element. And then we're gonna set our G and B pointer to point to the last element. Now, as we walk through our array from beginning to end, we're only going to have to walk through one time, so that's how we're going to satisfy that linear time requirement. As we walk through, we're going to look at the character and we're going to ask ourselves, is this an R, a G, or a B? And depending on which letter it is, we're going to swap it with that letter's pointer. So we're going to look at this first letter and it's going to be a G, so we're going to swap it with the pointer at G. So we're going to come over to here, we're going to say, okay, here's a G, we'll swap it with the G. In this case, it's the same character, right? But we're going to swap this G with this G, and then after we've made that swap, we're going to take the G pointer and move it back one index in our array. So we'd move it here, and then that means this would go away. So now our B is still at the end, our G has moved over one position, and our R is in the same spot. Now we look at our next We look at our R pointer again and we ask ourselves, where does this letter need to go? Well, it's a G, so let's swap it with the G pointer. So our G has moved, right? So now we actually have a new letter. So our G is going to go here and the R is going to go here. And then because we made a swap, that means we're going to have to move our G pointer back one, right? So now we do it again. Again, we look at our R pointer, we say, what letter is this? Oh, this letter is an R, which means we don't actually have to swap anything because that's the pointer we're already looking at, right? So this pointer, the R pointer, is going to be a little special in that we're going to move it to the right instead of the left. The G and the B's are kind of slowly moving to the beginning of our array, and the R is slowly moving to the right. And the reason I've decided to do that is because we want all the R's in the beginning, and we want all the G's and the B's at the end. Now we could do the same thing with our R and throw our R at the end as well, but then we'd need another index at the beginning to track where we're at. In this case, I don't really want to do that, so the R is kind of performing double duty here, which is why it's kind of this special case, but I think it makes sense here. So we found an R, so that means we're gonna need to move our R over, so we moved our R over 1, and now we do the same thing again. This is the last example we'll do, and then we'll actually start writing some code here. So we look at this character, it's a B, so that means we're gonna swap it with the character at the B pointer. And what was that? That was a G, yep. So then our G goes here. Our B moves over 1, like that. Perfect. And then now we would look at the G and etc. We keep swapping. Notice that we're starting to get things sorted, right? We have an R at the beginning, we have a B at the end, we've got a G here, and we're just gonna do this, you know, until these pointers have hit each other. And once they've hit each other, once the R has hit the G or the B, that means we've seen all the characters. Okay, that was kind of a long-winded example, but let's go ahead and get this going. I'm gonna take the test they've given us and move that into an actual test. So let's call this RGB test. And we're gonna use mini test for this. And we're gonna use mini test pride so we get color in our test output. And we also need to remember to require the actual file we're testing, which we've decided to call RGB. Now let's explain what that looks like. It's going to have one method on it, which we can call sort, because we're going to be sorting RGBs. And we can say exactly that. It sorts RGBs. Let's paste in our example and make this part of our test. So we're gonna sort this thing, and we expect to get back this thing. Okay, this looks good. Let's run it, make sure we don't have a syntax error. Okay, and we don't, but our failure is telling us we have not created our RGB class yet, so let's do that. And let's create the method we want to test as well, which we are calling sort, right? And this is going to take some characters as its input. Let's run it again just to make sure our syntax is okay. Okay, our syntax is not okay. We have a typo. Let's try this again. Assert equal. Okay, assert equal. Perfect. Okay, fixed our typo. That's why we keep running our tests over and over again, is to find those things. So let's open up our file again. Let's look at our error. It says we expected to get back a sorted array of RGBs. We got back nil. That makes sense because we haven't done anything, right? So let's return our characters. And here's a good failure. It's saying we expected to get back a sorted array and we did not get that. So let's leave that return in there because we know that we want to return that eventually. So we'll leave that at the bottom. Now let's create those pointers that I was talking about. So we're gonna have R, which is gonna start at the beginning of our array. So it's gonna start at 0. And then we have G and B, which is gonna start at the end of the array. So that's going to be char's size minus 1, the last index. Now, while those pointers don't intersect each other, so that's gonna be while R is less than G and R is less than B, we want to look at the character at position R, and we have several different cases that we might see. When that character is an R, then we don't need to do anything except for move our R pointer over one position. There's no swapping that needs to happen, right? So we can do plus equals 1. Now when that is a G, this is our first case where we're actually going to need to do some swapping like we saw in our example before. So when it's a G, we're going to take the character at the R position and swap it with the character at the G position. And then we're going to take that pointer at the G position and move it back one position. Now when that character is a B, it's going to be almost the same as this, except we're going to use the B pointer instead of the G pointer. So let's replace the G with the B and the G with the B and move our B back one more. And I think that's all we need to do. Let's fix our spacing, right? Is there anything else we're missing here? So while R is less than our other 2 pointers, we're gonna look at that character. If it's an R, then we'll just move our R index over. We don't need to swap anything. If it's a G, we're gonna swap the R with the G and then move that pointer back one. If it's a B, we're gonna do the same thing except with the B pointer. So let's run our tests. Okay, we have a typo. Let's fix it. We don't have anything called char. Did you mean chars? Yes, I did. Chars. I did it multiple times. Okay, excellent. This is going to be a good reason to use Vim's search and replace. So we're going to search for the thing that we just searched for and replace it with chars and do a confirmation. Yes, 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 yes. Okay, let's do it again. Okay. My caps key is stuck, so we are going to not do a search and replace. Okay, let's try running. Oh, we're missing our comma. I guess I did a search and replace on my comma. I'm very new to Vim, in case you haven't realized. Okay, so here we go. We ran our tests and everything passes. Excellent. So let's add a couple more test cases. I think the one they gave us is pretty good, but let's do a test with an empty array and a test with maybe one array, or one element in the array. So assert equal empty rgb.sort of empty. That looks good. Let's do just an R. That looks good. Let's try it. Okay. And let's do RGB that's reversed. I don't know why we're doing that special case, but might as well. So we're gonna expect RGB, and we're putting in BGR. Okay, great, that works as well. I think we're good to go. Let me grab what we've written here and throw it into a commit. So there's our code, there's our test. And this is going to be add solution for today, which is March 6th. Let's push it on up. Cool. So that's it for today. I had kind of a longer explanation on that one. I didn't want it to be too confusing. I wanted to explain what I was thinking. Thanks for joining me. Have a good weekend. I'll see you again on Monday. Bye.